Good morning students. Once again welcome to our channel. Today we are going to learn from standard 8th chapter number 1 mathematics, rational and irrational numbers. Now before we proceed, what are rational and irrational numbers, that we have to understand. So what are rational numbers? Suppose if the integers are in the form of P upon Q, where P and Q both are integers. P and Q are integers. When P and Q both are integers and we are having in the form of numerator and denominator, where Q is not equal to 0, then P upon Q is a rational number. Followed? P and Q are integers, and when the integers are in the form of numerator and denominator, where the denominator is not equal to 0, then the form P upon Q is called a rational numbers. So this is the definition of rational number. So now we will solve some examples where we can understand much more deeper. Practice set 1.1. Before going to practice set 1.1, we have to clear the concepts. Okay, most of the students don't know the concepts. For that I will draw a number line. Suppose this is 0, this is 1, this is 2, this is 3. Now when we have the number, suppose 5 upon 3, then 7 upon 3, then 11 upon 3. So at that time we have to see that the denominator is 3. That means when we have to show this number, these three numbers on number line, at that time you have to observe what is the denominator. If the denominator is 3, that means the single unit 0 to 1 and 1 to 2 and 2 to 3, this single unit from 0 to 1 has to be divided into 3 equal parts. Now this is a single unit. Now this single unit has to be divided into 3 parts because denominator is 0. Now here denominator is 3, 3, 3. That means a single unit should be divided into 3 parts. So for that you can divide it into 3 parts. So I will color that one part. This is one part, followed. Then this is second part. And this is the third part. See here, first part, second part and third part. So one unit is divided into 3 sub parts, 1, 2 and 3. So this becomes 1, this becomes 2, and 3 upon 3 is 1. So again this is divided into 1, 2 and 3, 1, 2 and 3, 1 and so on. Followed? So when the denominator is 3, at that time you have to divide the unit 0 to 1 into 3 parts, 1, 2 and 3 parts. Followed? For a next example we will see. Suppose now the denominator is 4. At that time this single unit has to be divided. This single unit has to be divided into 4 parts. See, denominator is 4, so 0 to 1 has to be divided into 4 parts. 1, 2, 3, and this is 4 part. 1 part, 2 part, 3 part, and this is 4 part. This is also 1 part, 2 part, 3 part, and this is 4th. 1, 2, 3, and 4. So depending upon the denominator, the single unit from 0 to 1 has to be divided into 4 parts. This is 1, this is 2, this is 3, and this 4 parts. Then only you can identify the given numbers on number line. Now I hope you have understood this concept. Now we are going to solve practice set 1.1. So chapter number 1, practice set 1.1. The question number 1 is, show the following numbers on number line. Show 3 upon 2, 5 upon 2, and minus 3 upon 2 on this number line. Now already I have told you that you have to first see the denominators. Now here the denominator is 2. That means a single unit from 0 to 1. If this is the unit 0 to 1, then that part has to be divided into 2 parts. This is 1 part and this is 2 parts. So I have already divided it. So now 3 upon 2. So from 0 you have to count 3 points. See here, 1, 2, and this is 3. So here you will get the point 3 upon 2, right? Then we have the second number 5 upon 2. Again from 0 you have to count 5. 1, 2, 3, 4, and this is 5. So 5 you will get it here, that is 5 upon 2. Then we have negative number minus 3 upon 2. So again minus means you have to count to the left hand side of the 0. So from here 1, 2, and 3. Here you will get minus 3 upon 2. Followed? So whenever you have to place these numbers on number line, you have to observe first the denominator. If the denominator is 2, divide from 0 to 1 and 1 to 2, 2 to 3 into 2 equal parts. Then each part will be counted as 1, 2, 3, 4, 5, 6, and so on. In the left hand side also the same. Second problem we will see. Now we will see the second example of practice set 1.1. 7 upon 5, minus 2 upon 5, and minus 4 upon 5. We have to show all these three numbers on this number line. So what is the denominator? 5, 5, 5. So if 5 is the denominator, at that time from 0 to 1, this part has to be divided into 5 parts. So 1, 2, 3, 4, and this is 5 parts. Similarly 1 to 2 is also divided into 5 parts. Here in this side minus 1, this is minus 2. So these are also divided into 5 equal parts. Now the first number is 7 upon 5. So this is positive. So we'll go beyond right hand side of the 0. So count 7. 1 from 0. 1, 2, 3, 4, 5, 6, and this is 7. So 7 you will get here this number. It is 7 upon 5. Here we got 7 upon 5. Second number is minus 2 upon 5. So come from 0 to the left hand side, count 2. 1, and this is 2. So here you will get minus 2 upon 5. Then second, what is second? Minus 4 upon 5. Third one is minus 4 upon 5. Minus 4 means again to the left hand side of the 0. 4. 1, 2, 3, and this is 4. So fourth you will get here minus 4 upon 5. So in this way you have to solve the number depending upon the denominator. Then if you have 6, you have 7, 8, 9. If it is 10, divide the one unit from 0 to 1 into 10 equal parts. So now we will go to see third problem. Now third problem we have minus 5 upon 8 and 11 upon 8. Now as the denominator is 8, we have to divide from 0 to 1 this unit into 8 equal parts. So it's here 1, 2, 3, 4, 5, 6, 7, and this is 8 parts. So 8th part will be the one number. Here also you have divided 1, 2, 3, 4, 6, 7, and this is 1, 2, 3, 4, 5, 7, and this is 8 part. Okay. Now first number we'll see minus 5 upon 8. So minus 5 means from 0 you have to count 1, 2, 3, 4, and 5. So this number you will get minus 5 upon 8. Next we will see 11 upon 8. So from 0 you have to count 11. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. This is 11. So here you will count it as 11 upon 8. So thus we have shown these two numbers on number line. So now here it is 13 upon 10 and minus 17 upon 10. These two numbers we have to show on this number line. So again the first step is what? Observe the denominator. If the denominator is same, that is 10, then the first unit you have from 0 to 1, you have to divide it into 10 equal parts. Here 1 and 2, 3, 4, 5, 6, 7, 8, 9, and this is last 10. So 10th part will be the 1. So 0 to 1 we have divided into 10 equal parts. Now the left hand side also we have divided the same. So 13 upon 10 positive number. So right hand side of the 0 will count 13 points. From 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, and 13. So this is our point. So this point is 13 upon 10. The next number is minus 17 upon 10. So from 0 you have to count 17. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17. So here is 17. So it will become minus 17 upon 10. So in this way we have solved the 4 problems of problem set 1.1. We will solve practice set 1.2. So in this, from first to 6 examples are very easy. Just by looking at them you can decide which is the smaller and which is the bigger, because this question deals with compare the following numbers. Now here we have to compare. Now the first we have seen, first problem is minus 7 and minus 2. From these two numbers you have to compare which is the bigger number and which is the smaller number. Now we have seen in the chapter integer part that positive numbers are always greater numbers, right hand side numbers are always greater than the left hand side, and if the two numbers are negative, at that time the smaller negative number is bigger than the bigger number. Okay, so now here two numbers are there. So whenever the two numbers are negative, always the smaller number is bigger than the bigger number. Okay, so in first example minus 7 and minus 2, as minus 2 is a smaller number, both the negative numbers are there, so smaller number is always greater, so you have to put the greater sign towards the 2. Then second example 0, and to the left hand side of the 0 there are negative numbers, So 0 comes in the right hand side and the negative numbers comes on the left hand side. So negative numbers are left to the 0. 0 is on the right hand side. So 0 is greater than negative numbers. 0 is always greater than all the negative numbers. Then third problem is 8 upon 7 and 0. So this is a positive number, so it will come beyond 0. If there is a number line, suppose here is 0, 8 will come beyond the 0. So 8 upon 7 is always greater than 0. Then again, fourth problem, this is a negative number and this is a positive number. So always positive numbers are greater than the negative numbers. As the denominators are 4, compare numerator number -5 and 1. So 1 is always greater than -5. So 1 is always greater. So 5 upon 4 is less than 1 upon 4. Then the fifth problem we will see. Denominators are same. So compare the numerator 40 and 141. So 141 is always greater than 40. So you will put greater number sign towards the 141. Then the sixth problem, denominators are equal, compare the numerators. So if both the numbers are negative, that means the smaller number is greater than the bigger number. So always the smaller number is greater than the bigger number. So here we have completed problems 6, because all these are of same type, just you have to compare just by looking at them. So from 7th problem, some certain problems are little bit different. So now 7th problem is 15 upon 12 and 7 upon 16. Now in these two we have to decide which number is bigger or which number is smaller. So looking at the figures we cannot decide, so there is a method that we have to cross multiply and see. So here we have to multiply 15 with 16 in this way, another problem in that way. So 15 into 16, then you can, then 12 into 7. Now what is 15 into 16? If you multiply 15 into 16, what is 15 into 16? You have to multiply 15 into 16. 6 5 are 30, 0, 3 carry, 6 1 6, 7 8 9, then plus 1 5 5, 1 1 are 1, you will get 0, 9 plus 5 is 14, 14 carry 1, this is 240. So here you are getting 240, then at this point you will get 12 sevens are 7 2s are 14, carry 1, 7 and 1 8, 84. So the left hand side is greater than the right hand side, so the same sign you will put it here. So 15 upon 12 is greater than 7 upon 16. So in this way you have to solve the problem. So the 8th problem is minus 25 upon 8 and minus 9 upon 4. So we will solve by cross multiplication. Again 25 multiplied by 4 and 8 multiplied by 9. In this cross multiplication you have to do. So first cross you have to do minus 25 into 4. So minus 25 into 4, then 8 into minus 9. 8 into minus 9. Now here you will get, first we will multiply the signs. Minus into plus is minus, 25 fours is 100. Now you can have this column of greater and smaller. Plus into minus is minus, 8 8 is 64, 8 9 is 72. Now both the numbers are negative, and we know that when both the numbers are negative, the smaller number is always bigger than the bigger number. So minus 72 is greater than minus 100. The same sign you have to put it here. So minus 9 upon 4 is the bigger number than minus 25 upon 8. So ninth problem, 12 upon 15, and the other is given 3 upon 5. Again the same method, cross multiplication, 12 multiplied by 5 and 15 multiplied by 3. So 12 multiplied by 5 and 15 multiplied by 3. So what you will get? 12 5 is 60. Now you can compare the numbers. 15 3 is 45. So easily you can tell that 60 is greater than 45. So 60 greater sign we will put. So this is 9 sum. You can take the screenshot. 10 sum we will see. So the last problem, 10th one, we have minus 7 upon 11 and minus 3 upon 4. Again the same method, cross multiplication, minus 7 into 4 and 11 into minus 3. So minus 7 into 4 and then 11 into minus 3. Here we get minus into plus. Minus into plus is minus 7 4s are 28. Now you can put the box. Then minus into plus or plus into minus is minus. 11 3s are 33. So again both the numbers are negative. Whenever the two numbers are negative and you have to compare, you can compare easily. Smaller negative number is always greater than the bigger negative number. So minus 28 is greater than minus 33. So in this way we have solved practice set 1.2. Next practice set we will see.